if you end up with an odd number there, try to make it an even number. By looking at the number of oxygens that we have in all three chemicals as the product, the only thing that we should do is to change the odd number 1 into an even number. So why do you do that? That's just, when you do balancing the equation by inspection, that's one of the things that you need to keep in mind. Why? I don't know. That'll make things a little bit easier. Okay, so take my word for it. If you put a 2 in here, that will give you 8 oxygens on the right, but it will also give you 2 coppers on the right. Now see, look what you did. We had two elements already balanced. Now you put a number in front of one of them, copper is no longer balanced. Well, we can always balance copper. 2 coppers on the left side, not on the right side now. All we need to do is to put a number in front of copper nitrate to balance copper. What number do we need?
2.
We'll put a 2 in there. Okay, that will give you 2 copper. How many nitrogen?
4.
Oxygen.
12.
I say you're making things worse. We had 2 elements balanced before we did this. Now everything is out of balance. Well, just one step at a time, you're trying to balance them out. So now you have 2 copper, 4 nitrogen, 12 oxygen. On the left side, you have 2 copper, 2 nitrogen. Well, we need 4. What number do we put in front of NO2?
4.
Well, we'll put a 4 in there just to give you 4 nitrogen. Okay? Now, if you put a 4 in front of nitrogen here, nitrogen dioxide, you get 4 times 2, 8. 8 plus 2, 10 plus 2. Balance? No. That's all we do. You do a bookkeeping there. Each kind of atom, you have the same number of each kind of atom on both sides of the equation. It's balanced. That's how you balance chemical reaction equation by inspection. Okay? You start with the easiest thing. When you start with the chemical reaction equation there, you say copper, we have 1 copper on both sides. We have 2 nitrogen on the left side, 1 nitrogen on the right side. Well, if you simply put a 2 in front of nitrogen there, and that will balance the nitrogen. And then you look at the oxygen there. You end up with an odd even number situation. You try to make the side with an odd number of atom even. And when you do that, you may change just the number of atom on that side. You may also change the number of atoms, a number of other atoms on that side as well. Now, you look at the changes that you have made and then try to make adjustments there so that you end up with balanced equation. So this is what we want you to be able to do. Given a balanced, given an unbalanced chemical reaction equation, you need to inspect the total number of atoms on both sides there. Make sure you come up with the same number of each atom on both sides of the equation there. So chem is try. Let's try this one. Methylbenzene, that's an organic compound. The carbon 6, hydrogen 5 represents a ring system where you have 6 carbons connected in a hexagon ring. And then you have a methyl group there. Now the correct formula, if you're only talking about the molecular formula there, if you do carbon 7, hydrogen 8, there's really nothing wrong with that. Carbon 7, hydrogen 8 is methylbenzene. You can do that. But the reason the organic chemists write out methylbenzene in the form of carbon 6, hydrogen 5, and then CH3 is because the actual structure for methylbenzene is that you have a hexagon ring of carbon connected to one another with alternating double bound and single bound within that ring. And then you have 1 hydrogen connected to each of the carbon in there, with the exception of this carbon the hydrogen on this carbon is being replaced by what we call a methyl group, CH3 group. So this is carbon 6, hydrogen 5. The benzene molecule, carbon 6, hydrogen 6. Okay? If you replace one of the hydrogen with methyl group there, then you have CH3 there. So that's the reason why we write the methylbenzene in. Now, if you look at this particular compound there, and this particular compound is what we call hydrocarbon. There are only hydrogen atoms and carbon atoms in this molecule, okay, hydrocarbon. Now, when you burn hydrocarbon in the presence of oxygen gas, you always get the same product, water and carbon dioxide. Okay, so if you burn gasoline is a hydrocarbon, you end up with carbon dioxide and more, depending on what else is mixed in the gasoline there. So if you have sulfur-containing compounds, if you have nitrogen-containing compounds mixed in the gasoline has a unnatural product from petroleum, it's very likely if the removal of the sulfur-containing compounds and nitrogen-containing compounds is not complete when you process petroleum there, when you burn gasoline there, you also generate, in addition to water and carbon dioxide, you also generate sulfur dioxide, sulfur trioxide, nitrogen dioxide. Those gases, if you emit those gases into the air, those gases will combine with moisture in the air and becomes acid. That's where the acid rain comes from. And your generation, you probably have not heard about that. And in the 70s and 80s and 90s there's a huge problem, environmental problem with acid rain. Because of the industrialization there, a lot of countries are burning a lot of fossil fuels without actually refine the fossil fuel before they burn it. So there's a lot of much higher concentration of the, in addition to carbon dioxide and water there, there's a lot of nitrogen dioxide and sulfur dioxide, sulfur trioxide emitted into the air. And then the rain comes in, the water mixed with those gases there, you end up with acid. And all those acids will destroy the crops on the ground and will destroy buildings there, because when acid is dumped on metals, a chemical reaction happens there. And acid also changes the pH of the soil. And most of the plants needs a very specific pH in order to survive. And if you change the pH there, they can't survive. Okay, so that's a side note about the chemical reactions in environmental science there. So what we have here is that we have methylbenzene. We burn methylbenzene in the presence of oxygen there, we generate water and carbon dioxide. Now, on the left side of the equation there, and by the way, it doesn't matter what sequence you use when you write the chemical there, when you write the chemicals in the chemical reaction equation. You can say methylbenzene reacting with oxygen, or if you switch the position there, it doesn't really matter. And these are the reactants. The product, carbon dioxide and water. If you do water and carbon dioxide, it's the same thing. You end up with the same product there. Okay, so it doesn't really matter how you write the chemical reaction equation, as long as you put the reactants on the correct side and the reactant product on the correct side there. So let's do a bookkeeping here. How many carbon do we have on the left side? 7. You have 7 carbon, 8 hydrogen, 2 oxygen on the left side. So 1 carbon, 2 oxygen, 2 hydrogen, 3 oxygen.